Hi, it's Jan Beta, and today I'm going to talk a bit about these Commodore 64 power supplies, which are not very good. So I want to try to make a replacement power supply in a pretty easy way for this thing that is a lot better. There are very sophisticated models that replace this one. For example, the one that Ray Carlson makes. I will link it in below. And there's also a more recent approach by Greisi, who made a video on that. I will link that in here and also in the description, so you can check out his work, which is very nice. It's probably my favorite, but it's there is an easy way to do this without much needed skills that I'm going to try today. So let me show you what I think is an appropriate way to replace this that isn't too difficult to handle. So what these are is basically they are supplying 9 volts AC at 1 amp and 5 volts DC at 1.5 amp. So yeah, that's basically all we need. So what we're going to do is to use the 9 volts, just a transformer from the mains to 9 volts AC, and we're going to use a pre-made 5 volts power supply. That is going to be a switching power supply, so it's going to be a lot better than what is in here, which is basically just a little rectification thing, some diodes, a capacitor, and a little 7805 voltage regulator that supply the 5 volts, which is what makes these things suck so badly, because the voltage regulator, if it fails, there's no protection in here at all, and these things fail pretty badly and deliver far too high voltages, or even too low voltages, which isn't good either. And these 5 volts are basically the voltage that powers all the ICs inside the Commodore 64. So these things are the main reason chips blow up, basically. So I'm gonna make a little replacement that is safer than this one, at least, because it uses a modern 5 volts supply. Okay, so here's what I'm going to do. We basically have our mains, in this case 230 volts AC, and they are going into a transformer that delivers 9 volt AC. So in these yeah, basically we have a fuse in here. Fuse on the mains. And this here goes to the computer. And then we have a parallel. In parallel, we have a little black box, which is a 5 volt DC PSU. In our case, the PlayStation Portable PSU. And we have 2 lines going on here, and we have this one fused. Oh, shouldn't write a D there. And yeah, basically this is our 5 volt DC, this is our 9 volt AC, sorry, that we need on our computer. So as easy as that, and that's actually more sophisticated really than the original PSU of the Commodore 64, because yeah, I didn't do any schematics for this, but this is a switching power supply, so it's way better than anything the old PSU has. And basically this part, the AC part, is exactly the same in the old PSU. So there's just a transformer, and the 9-volt AC are passed on to the computer. And inside the computer, these are basically fused too. That's the fuse in the Commodore 64 is on the 9-volt AC supply. So there's a fuse, or mains is fuse, which is always a good idea. There's a fuse on the 5 volts line because it's the most important line that breaks the ICs if something goes wrong there, so it's a good idea to fuse that at least. There's a fuse in the computer for the secondary, the 9-volt AC also, so everything's fused, everything's hunky-dory in theory. So you want to make sure that this is, in my case it's a 2 amp thing, this is 1 amp rated, I think. The original is 1.5 amp rated on 5 volt DC and 1 amp on the 9 volt AC. So I would suggest that you at least use 2 amps and at least 1 amp for the transformer. If you want to build something like this, then you should be fine. So yeah, that's about all the theory in this project. So the rest is just mechanical and soldering work and stuff like that. So let's get it on. So here's what I got to build this. Nice little case. I got this from some electronics supplier a while back. It actually took me some time to get to this point where I actually want to build this. I always procrastinated it a bit, and then Greisi's design came along and I wanted to build that, and then I didn't have enough money to let the circuit board that he made be produced and stuff like that. So I bought this stuff a long time ago basically, so now's the time to use it. So I bought this case, which is pretty nice, and yeah, it was pretty expensive in the end, but I think it's going to be a power supply that I'm going to use pretty often, so it doesn't hurt to have a good case. And this is the little transformer. So this is a primary 230 volts, secondary 9 volts transformer. You have to use one that matches your mains voltage, of course, and the output should be 9 volts. And 1 amp rating is okay. You could go a lot higher, of course, but this already weighs a bit, so it's quite a good transformer, I think, and it has a temperature fused in there in case it burns. Of course, you need a proper plug for the power supply. It is one like this. I will link in the exact model below. So I also got some fuse holders, 2 to be precise, because I want to fuse the primary side and the 5 volts side. So that's that. I also need fuses, of course, I haven't put them on here. And I have a 4-stranded wire. These are used for lamps and stuff like that usually. So I don't know the diameter off the top of my head, but it's reasonable for something like this, which doesn't have to use a lot of power. So and then I have it's actually the PSP, Sony PlayStation Portable power supply that I'm going to use, because it's quite a small form factor, and it's I don't know if you can see it. Yeah, there. It's a 5 volts, 2 amp power supply, switching power supply. So this is, I think it's quite good and reasonably powered for the job. And the mains cable, don't know where I salvaged this from, probably some DVD player or something I ripped apart for parts. But I also bought these things here, which are called grommets. These are basically for putting cables through cases without, these are made of rubber, so the cables don't get damaged. So that's basically all we need to build this. I'm also going to use some fuses, of course, and I think I'm going to go with some hot glue or stuff to fix this stuff in the case. But yeah, basically, let's see how this turns out. I haven't really planned this out in detail yet, but I have an idea about how this is gonna come together. So let's see. Okay, let's see how we could fit this in the case at first. And one thing I noticed is that I'm gonna use the cable that came with the Sony power supply because it's much better quality than the other one I showed you, the mains cable. It's very nice quality, so I'm gonna use that. Yeah, let's see. I think I'm going to, yeah, this is the primary, so here comes my, it's gonna be a tight fit. So, yeah, maybe something like this. Yeah, that's probably a good idea. Something like this. That's probably the best idea. So I am cutting this generously, like here. So yeah, let's do it here. Ah, nice cable. That's a good cable. And the other side as well. So I'm gonna leave a little more there, just in case. This can go away. Oh, this is a nice coaxial model here. Not too bad. So we are going to put our power cables in the center on the bottom, I think, and make a little fuse on each side, I think, so we can see which one is the mains fuse and which one is the 5 volts fuse. Okay, so as you can see, I managed to fit the fuse holders in there, and yeah, we're going to fit our stuff here, I think, because that's basically all there's to it. Yeah, should fit. Yeah, there we go. Not so bad. So of course it would be also possible to take this apart, but it fits like this and would probably be pretty painful to get this open without damaging the power supply inside, so I'm gonna try it this way. Should fit. So putting in the mains cable here through our little grommet. I'm thinking of Wallace and Gromit all the time. Do you know Wallace and Gromit? Pretty nice animated clay figures. Highly recommend it. Yeah, so what we're going to do now, basically, I'm going to pull this through a bit more. And going to strip the wires, and then the neutral, which is the blue wire, will go to the transformer and to the power supply directly, and the brown wire it will go through the fuse and will go to the power supply and to the transformer after that. So the mains is fused. the hot side of the mains is fused, which doesn't matter in Germany because our plugs, like in most of Europe, look like this, and they don't have polarity marked on them anyway, so either side can be hot or neutral. So, and I am putting on some heat shrink tubing because you can never be safe enough for added safety here. So yeah, I think I'm gonna make a knot in there and then put it through there, so we don't need much. So I made a little knot there so that you can't pull it out. That's safety measure. That's a very crude one, but yeah, it works. And I've seen this done in professional equipment as well, so yeah, that's a crude way. You could also use some cable ties and stuff like that, but I think this works pretty well, and I'm gonna go with it because it's my power supply. I'm going to solder this in on the fuse here before I go to there. That means I need a little cable there. That's not a big problem, I guess. So this one should go on there. And then we have to put this thing something like here. And yeah. Okay. Could work. This should be very nicely connected. We'll let it cool a bit. And then we're going to put the heat shrink tube over there, so it's nicely protected and no open. This is basically, if you plug in the plug, this is mains power. So we're gonna have some protection on there for safety. Safety. Okay, so this goes through the fuse. The blue neutral ones are going to the other pin of the transformer there. I'm going to use electrical tape to secure this part here and the other one. So for the 5 volts fuse, I'm also going to fuse the hot, which is the positive. So I am going to put the positive lead on here, or in here rather. There are little convenient holes in the fuse over there. So this goes over there. Some heat shrink, and this is the negative lead that we are just going to connect to the output there. Got this cable through the hole, which is pretty nasty to do because it's really tight. But I'm going to strip most of the insulation here, I think. So we are going to use the black and the yellow and green one for the DC, I think. So we have to note that down so that we can connect the plug in the right way. So I'll be right back. Okay, so here we go. I've written everything down there nicely. So let's connect these, I think. But I think I get out the hot glue now rather than later, because later we won't be able to reach any of these. So now I'm pretty sure how much space I'm going to need. So that's probably a good idea to do it now. Let's do it. Okay, so the brown and the gray wire go to our secondary on our transformer here. So we're gonna add some heat shrink tubing there, of course, because we can. So there's some heat shrink over there, and yeah, I think should do the heat shrinking stuff here, at least for some of the connections. So otherwise we have connected quite a bit here. So here's the product. Let's see if this still goes on there. Pretty nice. It's a very tight fit, I think, but yeah, and it even snaps in place pretty nicely. There's a quite healthy weight because of the big transformer in there. Nice, pretty tidy. So okay, let's put some finishing touches. I have to put some electrical tape over some exposed stuff here where I didn't put heat shrink tubing, and I think I'm also going to put some over here. Okay, so here's the cable that will be our Commodore 64 connections. So I'm already putting because I tend to forget this, already putting this over there. Forget this all the time otherwise. So this I can put on later. I'm gonna put this aside. I'm basically going to strip this and test the voltages and put some fuses in there. So here's our test setup. This is an FI switch that basically switches off the power if I touch anything, and my body becomes the connection to ground, so I won't get shocked for long, at least. This is one little safety measure that I'm doing here while working on this open circuit. So let's test the AC, which should be the brown and the gray wires here. The brown one and the gray one. And it doesn't matter which one I connect on which. Put this on AC and put in. And we're running 11.4 something volts AC, which is pretty nice without a load. Should be a bit more than with the load. So let's test the DC, which is on the black one, the positive, and the negative should be the yellow one. Here. So we are at 5.41 DC, which is nice. And by the way, the fuses I put in there preliminarily are on the primary a 0.315 amp, so 350 milliamps, and a 1 amp fuse on the secondary, which is the 5 volts output there. So I don't know if they are have enough oomph, but I'm going to try. I don't know exactly which voltage peaks the Commodore 64s reach, so we might blow a fuse or two before we have the right values there, but it should be sufficient for most stuff, I think. Yeah, let's solder on the connector and try. Okay, so let's go and solder on a connector. I have this pinout here, which I stole from Kreisi's Google account because it was just, well, he made this himself. I linked his video in the beginning where he builds the amazing Commodore 64 and 1541 power supply, and I just downloaded this below his video. It's the best image of this I could find, where it is clear that this is from the front, from the pin side. Most of the descriptions I found don't even say if it's the view from the solder side or the pin side. So if you ever do something like this, make sure you know which side the pinout is referring to. So this is from this side, the pin side of the connector. And as you can see, we just need pin 2, which is ground, pin 5, which is 5 volt DC positive, and we need the 2 pins 6 and 7, which are 9 volt AC. The other pins are not connected on the standard Commodore 64 and VIC-20 pin out for the power supplies. So let us solder on some wires, I'd say. I think I already mentioned before how much I love soldering these DIN connectors. It's basically just a pain to do it, but yeah. Any other connector, any other day, but these are pretty painful to do. So at least we don't need all the pins there. I think you could also heat those up and pull them out or something. The ones that are not needed, which would probably be a good idea. Don't really know. So the brown and the gray one are the AC ones. Let's put them in there. Did I mention I hate these DIN connectors? Yeah. Okay, so these plugs are pretty crap that I bought, but I have it assembled. Okay, so maybe this might be a good time to test it again. So I am going to test it after I checked it with the multimeter. Of course, I am going to test it on my Commodore 64 now. It should fit in there pretty nicely. Yeah, this plug is not perfect. It's not great, but it fits. I have to get another plug sometime maybe. So I have to go through all the DIN connectors soldering again. Yay! Yeah, so what I want to say is, let's try this. Okay, plugged it in. Okay, so it's plugged in. The monitor is running. Let's try and turn it on. And it blinked. And there we go. This thing seems to work. That's pretty nice. Let's try if everything works, if the SID works and stuff, because the SID is basically the only thing on these new boards that is powered by the 9 volts AC. So let's see about that. Yeah, so there's music, everything seems to work as it's supposed to. So this is a working Commodore 64 power supply, I'd say. Nice. For checking the voltages, you can use the user port. The 5 volts are between there's 2 little gaps. One gap is here, and the other gap is here. You get 5 volts DC on the output here, and you get 9 volt AC between the 2 pins next to the gap here. So that's pretty easy to get access to the voltages to test them. I did that. It's pretty hard to show it on camera, so I'm just going to tell you. The 5 volts are pretty much 5 volts DC. The 9 volt AC are about 10 volts AC, but they are the same with the original PSU, so that's absolutely fine. And yeah, so that works very well. Okay, so it seems to work pretty nicely. Only thing that's really left to do is to secure the cable inside here, which isn't really necessary because it's really hard to move. But I'm gonna. I think I might just use a cable tie or something on there. Yeah, that's probably a good idea. I recently found out about these pink cable ties, and now I have to use them all the time, of course, because So this is my new Commodore 64 power supply with screws and everything, and it also works. So turned out pretty nicely, I think. And also the case is not perfect, but it's a nice case and it should do the job pretty nicely. And it's a little smaller even than the original PSU, I think. Just a tiny bit. So pretty nice. So I gave this power supply some testing, and it seems to work just fine. And it's a bit warm, but it's not hot or anything. It's like lukewarm, not even, yeah, it's not even really warm. Can barely feel it. Pretty nice. So I'm quite satisfied with it so far. It's a working replacement power supply for the Commodore 64. And it also looks pretty tidy, I think. Turned out pretty well. So that's it for now. I have to give this some more testing, of course, and if anything breaks or goes wrong, I will notify you with a new video. But yeah, this is probably going to replace the original power supply that I had in use. That is, you can see it in the back there, these fins there. Yeah, basically this is a better power supply probably, so I'm going to use that. Thanks for watching. Hope to see you again on my channel. If you want to support me in any way, you can give this a thumbs up, of course. You can subscribe to my channel if you haven't done so. You can also check out my Patreon page, where you can support me with some money and help me buy more interesting stuff and make stuff like this, because I had to buy the components basically. And yeah, hope to see you again on this channel sometime soon. Thanks for watching. I'm Jan Beta. Bye!